All right, well, we're starting Unit 6 now, which is a unit on rational expressions and rational functions. Um, the test for this, if your A day, will be on Friday the 15th of December, and if you're on a B day, it will be Monday the 18th of December. So make sure you have that test taken before the break. So today we're going to work on simplifying and multiplying and dividing rational expressions. So we're going to start with these two. We had you practicing this after the test, except for just kind of some more simple cases that only had one variable. But these examples are not really much different than the ones that we were working on. You would just consider each of the variables in turn and of course the numbers. So we have a 16 over 18 as the numbers in this fraction, and hopefully you recognize that that reduces to 8 over 9. The reason that that works is you could think of that 16 as a 2 times 8. You can think of that 18 as a 2 times 9. And then, of course, you could reduce that factor of 2. So the number portion of this is going to be an 8 in the numerator and a 9 in the denominator. And now we'll just consider each of those variables in turn. If we're thinking about the x values, we have an x to the power 1 in the numerator. We have an x power 5 in the denominator. So we've got x to the 4th in the denominator when we reduce one factor of x. For the y's, we have y to the 3rd in the numerator, and we have 1 power of y in the denominator. So it looks like we're going to have y squared in the numerator. And then finally, if we look at the z's, we have just one factor of z in the numerator and denominator, so that would reduce. So here's our solution, 8y squared divided by 9x to the 4th. One for you to practice here. If we think about the numbers here, 8 divided by 2 reduces to 4. And if we consider each of those variables, we have an x to the 3rd in the numerator and an x, that would be an x squared. And then we have a y, and it's divided by a y squared. So this would reduce to 4x squared divided by y. Okay, so rational expressions are the ratio of two polynomials. So ratio is kind of like the math word for fractions. So what we have is a fraction in which both the numerator and the denominator are polynomials, and this is a rational expression. So today we will be working with these. Today we'll be simplifying, multiplying, and dividing. Next time we'll work on adding and subtracting. So first of all, I've got this fraction rule up here. So when you're simplifying a rational expression or a fraction, if you have a times c and you're dividing by b times c, you can reduce a factor of c. Now that works with numbers, it works with rational expressions as well, so long as the operation between the a and the c is a multiplication operation. That's just a fraction rule that I'm hoping you're familiar with. Now, sometimes people also think that this would be okay, that if you have a plus c divided by a plus b, that would reduce. But that is not the case. That does not work. It is not equivalent. So make sure that you are really careful that you don't reduce things that are being added. Okay, so let's look at this example right here. 3x divided by 4x. This is 3 times x divided by 4 times x. So it is fine to reduce that factor of x, and this is equal to 3/4. But this next example, x plus 1 divided by x plus 2, the operation between these two terms in the numerator is addition. The operation between the two terms in the denominator is addition. Nothing can be reduced there. You cannot reduce a factor of x. that would be your solution. It doesn't simplify at all. It just is what it is. So I hope you can see the difference between these two cases, because this is sort of really important idea for our whole unit. It's okay to reduce factors or things that are being multiplied together. It's not okay to reduce things that are being added. So in this next example, we have 2 times the quantity of x plus 2. That's being multiplied, and we're dividing by x plus 2. Well, we can't reduce the x's like over here. We absolutely cannot do that. But it is okay to reduce a factor of x plus 2. It's like having 2 times something divided by 1 times something. Sometimes if you look at it with numbers, it makes more sense. 2 times something divided by that exact same thing is just 2, and this is exactly 2 as well. So it is okay to reduce a factor of x plus 2. It's not okay to reduce an x that is part of a factor, though. So look at those 3 examples and see if you can tell the difference between those 3. It's very important. So a lot of what we'll be doing this unit is that we're going to be looking at expressions and factoring them so that we can decide if there's anything that we can reduce. So if I look at the numerator here, is an x squared plus 5x plus 6, we can factor that as an x plus 2 and an x plus 3. And if I look at the denominator and I think about if I am able to factor that, it's an x GCF, a common factor of x we can factor out, and an x plus 3. So when we look at this, this rational expression in its factored form, we can see that a factor of x plus 3 does reduce. So our final answer will be x plus 2 over x. So we can reduce factors that are in the numerator and denominator, but not terms. So your mantra for this entire unit is factor first. Whatever you're doing, factor first. Just absolutely do not do this. This is absolutely not true. If you do that, you are making an error that is not right. So make sure that you're really careful to not reduce a term like that. You have to factor first. Okay, so let's try a couple. Remember, factor first. So if we factor the numerator of this expression, it would be x times x plus 4. There are loads of GCFs this unit. So as you're factoring, if you're stuck on one, check and see if it's a GCF. So in the denominator, we have x squared minus 3x minus 28. So that would be x minus 7, x plus 4. So as we have that factored, we can see that we can reduce the factor of x plus 4, and our solution, or our simplified expression, would be x divided by x minus 7. So in the numerator, we have the factor x. In the denominator, we have x minus 7. Let's try one more of these. X squared plus 2x minus 15 factors as an x plus 5 and an x minus 3. Our denominator factors as x minus 8 and x minus 3. So since we have an x minus 3 and an x minus 3 in both the numerator and denominator, we can reduce that. So our solution would be x plus 5 over x minus 8. All right, so I want to look at a couple of fairly simple expressions. Simple in terms of that they're not giant with a million different terms or factors, but these ones are unique because every single one of these is actually just equal to the number -1. So we want to start being able to recognize these so that if you see something like this in one of your more complicated expressions, or if you see something like this, that you're able to reduce it correctly. So we're going to start with this first one, negative 7x divided by 7x. Hopefully that one's easy for you to recognize as a negative 1. The x would reduce, the 7 would reduce, and what we're left with is just negative, and it would be negative 1. So, you know, if you have 3 divided by 3, it doesn't go away, it doesn't become 0. 3 divided by 3 is equal to 1. So this would be negative 1, since both the numerator and denominator are the same, except for that negative sign. So in this second case, x plus 2 divided by negative 1 times x plus 2, the x plus 2 absolutely can reduce. That factor is exactly the same in the numerator and the denominator, but it doesn't reduce to 0. We would maybe think of it as a 1 divided by a negative 1 if you want, and that's, again, just equal to negative 1. So we have these two are both equal to negative 1. I think it's a little bit less obvious maybe for this third and fourth one. Those first two, I think most people are pretty able to see. So our numerator, we can't really do much with that, but the denominator does have a common factor of negative 1. So we can factor that out. If we factor an x out, or a negative 1 from this first term, negative x, that just leaves the x. And if we factor negative 1 from a negative 4, that becomes a positive 4. So you can see that the term here, x plus 4, is present in both the numerator and the denominator. We can reduce it to negative 1. This last one is by far the hardest for people to see. The denominator is not written in standard form, so I'm going to rewrite it in standard form. This term x that's negative comes first, and then we have a positive 5. Okay, so the negative is with the x, and the 5 is positive, so it's a negative x plus 5. So now that we have it written in a more standard form, we could factor it a teeny bit. Because this leading term here is negative, we are going to want to go ahead and factor out a negative 1. And when we do that, that first term is just an x. And if we factor a negative 1 from a negative, or from a positive 5, it is going to be a negative 5. If you times these two things together, that gives you that positive 5 that your expression has. So now that we have it factored with that negative 1 factored out, you can see that those two factors reduce, and we again have this case of a 1 divided by a negative 1, which is just positive, or negative 1. So as you're factoring, if you see something that is kind of close to being similar, but some of the signs look funny, it could be that you need to factor a negative 1 out. So here's a couple examples of that. This first one is not written in standard form. So if we rewrite that numerator and put that highest power term, that negative x squared, first, it would look like this. Factoring with a negative x squared is difficult, so that's why we want to factor that negative 1 out. So this becomes positive x squared. The negative 5x becomes positive 5x, and the positive 14 becomes a negative 14. And then we could factor that a little bit more. We can factor that as an x plus 7 and an x minus 2. So once we have our expression factored, we can see that the factor x plus 7 reduces. So our solution would be negative x minus 2. Or if you prefer, you could write it as a negative x plus 2 with that negative distributed. Either one of those is fine, and really that's the same as this if you prefer to not have that negative coming first. Either of those answers are correct. It matters not to me how you write it. Okay, so let's look at one more of these. X plus 4 is our numerator. Our denominator is not in standard form, so I'm going to go ahead and write it in standard form. So in that denominator, it's now leading with a negative term, so we're going to factor that negative out, leaving us an x squared minus 16. And that would be x plus 4 and x minus 4 if we factored the x squared minus 16. That's a difference of squares. So here we go. We can reduce the x plus 4, and that leaves us with 1 over negative x minus 4. If you want, you can put the negative. Sometimes people put the negative in the numerator like this. Either way is fine. It's not, they're the same. All right. So just watch out for negative ones if you see some sign issues. Okay, so we need to learn how to multiply these things and add these things, or sorry, oh my gosh, goodness, my brain today. We need to multiply and divide now. And the processes of multiplying and dividing are very similar. There's just one small difference. So let's start with multiplying. Hopefully you remember your rule for multiplying fractions, and that is if you have a fraction a divide by b, and you want to multiply that by c over d, it's just a c over b d. So if we looked at this 3 over 8 and we times it by 1/3, it would just be the same as 3. That's the 3 times the 1, and we would divide that by 24, which is the same as 1/8. So you might notice looking back that it would be possible to reduce that factor of 3 and leave us immediately with that 1/8. We can think of that with our rational expressions as well. If we have x plus 5 over x minus 6 and we're multiplying it by x minus 6 over 3x, we can absolutely reduce that factor of x minus 6. And the reason that works is because this is exactly the same as just having it written like this. It's no different. So as long as one of the factors is in the numerator and one of the factors is in the denominator, you can absolutely reduce a factor like that. So our final answer here would be x plus 5 over 3x. Now again, remember, as we're working with these rational expressions, we need to always remember to factor first. So here is our first one. I'm going to highlight the one I'm factoring as I go along. Okay, so 2x squared plus 7x plus 3, we need to factor that. Sorry. So we would factor that with a 2x and an x, and we're thinking of the factors of 3. So let's see, if we put our 3 here and our 1 here, that's going to give us a 6x and a 1x, which will definitely add up to 7 like we needed. So here's our two factors. We need to put positive signs in there. Okay, so now let's factor the denominator of this expression. X plus 2 and x plus 3 are going to be the two factors of x squared plus 5x plus 6. So you can see before we even go any farther, we already have one factor that reduces. So let's go to this expression. We're multiplying by x squared minus 3x minus 10. So that's an x minus 5 and an x plus 2. And in the denominator, this one's a little tricky for people to factor sometimes. It's a 2x squared plus 1x. So what we can do to factor that is that it has a common factor of x. When we factor it out, it leaves the 2x plus 1. So now as we look at our expression, it's really just like having one big numerator and one big denominator, because these are all just being times together on top, all just being times together on the bottom. So we can go ahead and cancel this x plus 2, and we can also cancel this factor of 2x plus 1, which leaves us with x minus 5 over x. Okay, let's try one more of those. Shrink this down a little bit. maybe. There it goes. Okay, so we're factoring now over here. We need to factor each of the parts of this expression. So that first one, it's not in standard form, so I'm going to rewrite it as a negative 3x squared plus 3x. So I'm just switching the order of those terms. So what we can do there is factor out a negative 3x. I chose negative 3x because that leading term is negative. So if we factor out a negative 3x, that first term will leave an x. And this second term is a little tricky. If we already have the 3x there, we're trying to factor it out, it's going to leave a 1. And because we're factoring out a negative 3x, that's going to be a negative 1. Okay, so now we can factor the denominator of this expression. We're thinking of factors of negative 2. So it looks like this will be x plus 2 and x minus 1. Over here we've got a cube pattern, x to the third plus 8. Well, remember 8 is the same as 2 to the third. So this is going to have a factor of x plus 2. And then we need an x squared because our original is an x to the third. And it's going to have to be a 4 here to get a positive 8. And then just remember, you need to also come up with this middle term that helps cancel out the other terms. And it's going to be a 2x. If you're still struggling with that cube pattern, come in and we'll work on it and practice it a little bit because you can totally get it down. Just maybe need a little more practice if that's still really difficult for you. Okay, there's not a lot we can do to factor that denominator 3x. It's already 3 times x, so it's good to go. All right, so let's see what we can reduce. X plus 1's reduce, x minus 1's reduce, x plus 2's reduce, and then we also can reduce the 3x. Be careful though, that leaves that negative there, and then we also have this quadratic, negative x squared minus 2x plus 4. You can leave it like that if you want, or you can go ahead and distribute the negative if you like. Either of those answers is fine. Remember, since that quadratic came from the cube pattern, it is not factorable. So we can't factor it. If we could factor it, you know, if it was something that was factorable, we'd probably want to try to factor it, but it's not factorable. Okay, there's one for you to try. I'm going to factor it fairly quickly. It would probably be best if I were you, I would pause the video and try to do it yourself. And then just check your answer to make sure that you're doing well. But I'm just going to factor it pretty quickly here. So we have it all factored, and now we just can look to see if any of our factors reduce. X plus 2 reduces, x minus 4 reduces, x minus 2 reduces. And remember, to reduce, it has to be a numerator and a denominator. It can't be 2 things in the top or 2 things in the bottom. So we would have the solution 5x divided by x plus 8. Okay, one last thing to talk about is dividing. Dividing fractions is very similar in a lot of ways to multiplying fractions. It's just that, in fact, what we do is we reduce division into multiplication by acknowledging that dividing fractions is the same as multiplying by the reciprocal. So A over B divided by C over D is exactly the same as A over B times, and we do the reciprocal only of the divisor, D over C. So if you remember to do your reciprocal, it's actually exactly the same as multiplying. So this would be 3/5 times 7/6. And we could think of that 6, if we wanted, as a 3 times 2. So we could reduce a factor of 3, and our answer would be 7/10. So let's try that with rational expressions instead of numbers. If we want to, we could do x plus 2 over x minus 1. Remember, that one doesn't change. And now, instead of dividing, we're going to multiply by 3x over x plus 2. So once we realize that we're just multiplying by the reciprocal, we can reduce that x plus 2, and our solution would be 3x over x minus 1. So again, the types of things that we can reduce are factors, not terms. So as we're doing this process, we have to remember to factor first before we can reduce. So here's one to try. 7x divided by 2x minus 10. And we're dividing that by x squared minus 6x over x squared minus 11x plus 30. So this first one would stay the same. We don't change that at all. But we can turn this into multiplication. So now we're going to times by x squared minus 11x plus 30 over x squared minus 6x. So to reduce it, or to see what reduces, we just need to factor everything. We can factor a 2 out of this expression, and it's going to be 2 times the quantity x minus 5. If we factor our numerator here, it's going to be x minus 5 and x minus 6. And our denominator has a GCF of x that we can factor out. So now that we have it factored, we can look for things that reduce. We have an x minus 6 over x minus 6. We have an x minus 5 over x minus 5. And in fact, we could even reduce this factor of x, which leaves us with 7/2, or if you prefer, you could write 3.5. Okay, one for you to practice. So if I were you, I would try to do this on your own. Pause the video. It has lots of GCFs, so as you're factoring, look for GCFs. And remember that since this is a division problem, we are going to have to do a reciprocal here. So I'm going to go ahead and factor it fairly quickly once I have this reciprocal written. Okay, so pause and try it on your own. It's a little bit tricky. Okay, we can factor a 3 out of that denominator. That leaves a 2x minus 1. We can factor an x out of this numerator. That leaves a 2x minus 1. We can factor a 3x out of the denominator. That leaves x minus 4. So we can reduce this, we can reduce that x. And what we're left with right now is a 9x squared in the numerator. And in the denominator, we have a 3 and a 3 and an x minus 4. That is a 9 times x minus 4. So we could also reduce that 9. So our solution would be x squared over x minus 4. Okay, so compound fractions, this probably maybe looks horrifying to you. It's actually just exactly the same as what we were just doing. It's just written in a slightly different way. So this would be the same as saying I have this fraction, 3x minus 6 over 3x squared plus 12x, and I'm dividing by this fraction, x plus 5 over x to the third plus 5x squared. It's no different. It's the same. So you can do it exactly the same way. You can just multiply by the reciprocal. But in fact, sometimes it's almost easier when it's written like this, because I wouldn't personally rewrite it like that each time. What I would do is just say, okay, I'm dividing, so I want to multiply by the reciprocal, and it's kind of nice because it's already sort of has this empty spot for you to write it on. Now that I've written it as a reciprocal up there, I can just continue doing my problem. So I'm going to go ahead and factor everything, starting with this. So we've got a 3x minus 6, so we can factor a 3 out. In the denominator, 3x squared plus 12x, we can factor a 3x out. On the other side, on this other expression, we can factor out an x squared. And the denominator we can't really factor. It's already its own little factor. So we can cancel or reduce that x plus 5. The 3 can reduce, and we have x squared and x, so one of those can reduce, leaving an x in the numerator. So you have an x and an x minus 2 in the numerator, and an x plus 4 in the denominator. Okay, there's one there for you to try. I'm going to go ahead and do both of them fairly quickly so you can check yourself. So I'm doing multiplying by the reciprocal here. So this is gone. So if we factor the numerator there, we have this. This would reduce. And be careful here, sometimes people want to cancel out the x plus 2, but it absolutely does not reduce because they are both in the denominator. So it would be this. You could write it as an x plus 2 times x plus 2 if you want, but it is, you could use that exponent notation. Okay, so one more. I'm going to multiply by the reciprocal. Okay, so this is gone. If we factor all of this, this is not in standard form right now. I'm going to factor out a negative x. That's going to leave an x minus 3. X plus 9 and x minus 2. Again, I'm just factoring that quickly because I'm hoping you factored it and you're just checking yourself. The x plus 9's reduce, x minus 2's reduce, the x reduces. So in the numerator, it's going to just be 1, and in the denominator, we have negative and x minus 3. So we could write that as this, or we could write it as this, or you could even write it like this. Any of those would be fine. All right, so that's it for lesson 1. If you have questions on your homework, come in, talk to your teacher, and we'll get you some help and some practice on that. Thank you.